There's a real famous scene from the 1994 film Dumb and Dumber where Lloyd Christmas, played by Jim Carrey, asks Mary Swanson, "What do you think the chances are of a guy like you and a girl like me ending up together?" And Mary eventually says his chances are like 1 in a million, to which Lloyd famously responds,
"So you're telling me there's a chance?" Yeah!
Now, chance can mean different things. In some cases, it can mean to say there's a possibility of something happening, such as there's a chance it will rain tomorrow, or Lloyd Christmas has a chance with Mary Swanson. The other meaning for chance is as a synonym for probability, which may or may not invoke possibility, such as the chances are 1 in a million. So what I'm going to talk about today is probability and how it's related to possibility. So I guess our real focus is, what is probability? In a 1929 lecture, Bertrand Russell once remarked, quote, "Probability is the most important concept in modern science, especially as nobody has the slightest notion what it means." Now, if you've been around my channel, you'll know I have differences of opinion with Russell on a lot of things, but this is something I actually agree with him on, at least in spirit. Despite the fact that a lot of us use statistics and probabilities every day, many of us don't have a clear idea of what is meant by the word probability or chance, and whether these words refer to anything that exists at all. Italian statistician Bruno de Finetti went so far as to open his 2-volume treatise on probability by declaring, quote, "Probability does not exist." Regardless, I side with the engineer Richard Hamming, in that our use of probability cannot be separated from its underlying philosophy and interpretation, and thus it's important to critically reflect on what probability is and what it means. And as you'll see, there's actually many competing views on what probability is, which can cause all sorts of confusion when discussing the concept. My goal here isn't to tell you that one view is superior to another, rather it's just to discuss these different interpretations and some of the problems with them. With that being said, there is one perspective I think is clearly superior, so I'm not going to claim to be completely unbiased in this video. Now, to be clear, virtually everyone in statistics and philosophy of statistics agrees with how probabilities are defined, which is Andrei Kolmogorov's famous axiomization of probability into a sample space, an event space, and a probability measure. What is less clear is what the meaning of these terms are and how they relate to our everyday experience. What is worth mentioning is this axiomatization came much later, after hundreds if not thousands of years thinking about probability. So in this video, what we're going to do is discuss the meaning of statements like, quote, "The Democrats will probably win the next election," "This coin is just as likely to land heads as tails," and "There's a 30% chance of rain tomorrow." I get these examples from statistician and philosopher Alan Hayek, who wrote the wonderful Stanford Encyclopedia of Philosophy entry on interpretations of probability. Seriously, you should just read it. It's one of the most interesting and best papers I've ever read, and Hayek has made serious contributions to both philosophy and statistics. This video takes some inspiration from Hayek, but because my field of study is closer to statistics than philosophy, I'll be giving a different perspective, and one that'll probably be more familiar to statisticians than to philosophers. Anyway, let's begin by talking about a feud between two rival groups that see probability in fundamentally different ways. Now, this feud isn't exactly bloody, at least not to my knowledge, but it has divided statisticians and philosophers for centuries. This feud is between the Frequentists and the Bayesians, and their difference actually cuts at the heart of what the notion of probability or chance is supposed to capture and what it means. Consider what L.J. Savage wrote in 1954. Quote, "It is unanimously agreed that statistics somehow depends on probability, but as to what probability is and how it is connected with statistics, there has seldom been such complete disagreement and breakdown of communication since the Tower of Babel." Let's start with the Frequentists. The Frequentists see probability in terms of frequency, where the probability of an event is the proportion of the number of times you see an event over the total number of trials. This view is often implicit in examples like coin flips or card draws, where you can easily imagine a large number of trials. I say the probability of a fair coin turning up heads is 0.5 or 50% because if I keep flipping the coin, I expect the number of heads I see to be half the number of coin flips. Here's a little simulation I ran with the fair coin, and notice how as we increase the number of coin flips, we sort of converge at 0.5, which is why the frequentist would say the probability of the coin being heads is 0.5. The probability of a coin flip landing on heads is literally defined in terms of this, in terms of the number of times you would see it over the total number of flips. Famous frequentists include John Venn, the diagram guy, Sir Ronald Fisher, and David Hume. The Bayesians, on the other hand, view probability as a measure of confidence in one's belief, open to being updated in light of new evidence. This idea was summarized by Augustus de Morgan in his 1847 volume on formal logic, where he wrote, quote, "By degree of probability, we really mean, or ought to mean, degree of belief." As a result, Bayesians often see probability as a subjective rather than objective feature of the world. While there are some Bayesians who try to take a more objective view of probability, this view is pretty rare because Bayesian reasoning incorporates background knowledge, which tends to be subjective. A coin is flipped and lands heads, but this result is hidden from you. You may assign a probability of 0.5 to heads and 0.5 to tails, but once you see the coin, you'll update your probabilities to be in line with the evidence that you see, so heads with probability 1 and tails with probability 0. This idea of updating your beliefs is at the heart of Bayesian reasoning and the Bayesian view of probability. Famous Bayesians, of course, include Reverend Thomas Bayes and Richard Price, the aforementioned De Morgan, and E.T. Jaynes, who may have been the most hardcore Bayesian of all. When a Bayesian says, quote, the Democrats will probably win the next election, what they are really saying is, I believe the Democrats will win the next election, or if I had $100 to bet, I'd bet more than $50 the Democrats will win. This relationship of probability to a rational agent's betting habits to avoid getting duped is called a Dutch book argument, and was coined by Frank Ramsey in his 1926 work, Truth and Probability. Now, some people are quick to side with the frequentists rather than the Bayesians because the frequentist view, at least on the surface, may seem to promise a more objective view of probability. However, to think this would be to make a serious error. In fact, the frequentist view may be more subjective because it needs to hypothesize repeats of events where such repeated occurrences are dubious and highly speculative, if not outright impossible. For instance, consider claims about historical events, things that have already happened. When we say it is unlikely but it happened, what exactly are we using to make our judgment? Or consider future events. What does it mean to say there's a 30% chance of rain tomorrow? Well, there's only one tomorrow. How can we in principle repeat this to make such a decision? At this point, the frequentists may point out that we have had many other tomorrows in the past, but it's unclear which previous days are relevant to the current context. Is it all days throughout time? All previous days at any location, or just at the current location? Deciding what events to use and which ones are relevant to the current context is called the reference class problem, and was coined by Hans Reichenbach in 1949. While Hayek argues, in my view successfully, that the reference class problem is present in any substantive interpretation of probability, which of course includes Bayesian views, the reference class problem is particularly problematic to the frequentist because the frequentist interpretation of probability is more intimately connected to what are called counterfactuals. Now, a counterfactual, literally a counterfact, is a way of considering things that didn't happen but perhaps might have. We tend to look at the world around us and imagine some things could have been different. Say I roll a die and it comes up as a 3. But if I'd rolled the die differently, it might have come up as a 6. This is an example of a counterfactual. When a frequentist says something like the Democrats will probably win the next election, they are implicitly saying if the next election was to be repeated many, many times, whatever that means, Democrats would win more of these hypothetical elections. If these hypothetical elections differ in some way from the actual course things take, then this argument invokes counterfactuals. The point here is considering counterfactuals involves subjective judgments about what one believes could or would have happened. We have no direct access to these other realities, or what are sometimes called possible worlds, so frequentist statistics isn't necessarily any more objective than Bayesians, it's just different. Let's give an example of why we need to be careful with probabilistic language and these underlying assumptions. In the late aughts, there was a bus campaign in the UK sponsored by Richard Dawkins and the British Humanist Association that read, quote, there's probably no God, now stop worrying and enjoy your life. And of course, we need to ask what is meant by the word probably, which sounds like an appeal to probability. Now, clearly, if it was a frequentist saying this, they would be blasted for incoherence. What does it mean to have many universes? Some where God exists and created them, and some where God doesn't exist. This is required for the frequentist to be able to make this kind of statement. In fact, following Plantinga and Anselm, taking God seriously means if God exists in any possible world, he exists in all possible worlds, since God is being to its maximal degree. So instead, a better interpretation, out of charity, is to assume this campaign is implicitly adopting a Bayesian view. But then this interpretation suggests that the use of the word probably is merely subjective and relative to one's background knowledge. What I think is misleading is the appeal to probability in what may sound objective. Notice the bare assertion, there's probably no God, without reference to any prior, but under the surface using probability only as a subjective measure of belief. So making it sound objective when actually it takes a subjective view of probability. Now, I'm not necessarily trying to accuse the British humanists of being deceptive or using subterfuge here. I think a better interpretation is they just didn't reflect enough on their use of probabilistic language for their point to be clear. And let's be honest, the point of this whole campaign appears not to be making a rational argument, but instead to be influencing the public. And this should make sense. I believe they were reacting to a bus campaign by the website JesusSaid.org that provided a link to a website saying non-Christians would burn in hell for all eternity. Again, the way you see these arguments in public isn't necessarily a logical argument. The point in all of this is to show how pervasive probabilistic language is in everyday discussion, despite the fact that different uses of this term may imply one view of probability more than another, sometimes within the same conversation. As a result, I'm a bit cynical in that I often think when you hear people say the word probably in everyday discussion, their use of the word is more rhetorical than logical. In other words, I'm not confident that most people have sufficiently reflected on what probability is and what they mean by such statements to make their usage of words like probably or probably not all that coherent. Now, there are other interpretations of probability besides the frequentist and Bayesian views, but these aren't as popular. Let's run through two more briefly, and I'll explain some of the issues behind these as well. The classical interpretation of probability is similar to the frequentists, but rather than counting occurrences of outcomes, it uses the number of ways an event could happen as the numerator and divides by the total number of possible outcomes on the denominator. In other words, it counts possibilities, not actualities. This relies heavily on what is called the principle of insufficient reason, or Laplace's principle of indifference, which says that in the absence of any information, we shouldn't favor one outcome over another. In other words, without any additional information, we should give each outcome the same probability as not to arbitrarily favor one over another. For instance, if we have a die with 6 sides, we let the probability of rolling any one of those faces 1/6. We have a deck of 52 cards, we assign the probability of drawing a single card to be 1 over 52. Mathematician Abraham de Moivre, who wrote a famous treatise on probability that apparently was highly prized by gamblers, explained this view. Quote, if we constitute a fraction, whereof the numerator be the number of chances whereby an event may happen, and the denominator the number of all the chances whereby it may either happen or fail, that fraction will be a proper designation of the probability of happening. Now, you may have been taught this view of probability in school, especially if you were taught probability in the context of examples like dice and card games, but there are some serious issues that keep this from being taken seriously by statisticians. These issues come from the assumption that each outcome is equally likely, which isn't necessarily a bad assumption in many cases, but isn't always reasonable to assume. For instance, this assumption means that the classical view of probability does not allow us to reason about the probability of, say, sides of a weighted die or an unfair coin any differently than a fair die or a fair coin. Consider an unfair coin. If there are only 2 possible outcomes, the classical view says that each has a probability of 0.5, regardless of what you actually observe by flipping the coin. This explains why the frequentist view rose to prominence, as rather than looking at possibilities, it requires actually performing the experiment in question. Similarly, the Bayesian would say you start with a certain assumption and then you update your beliefs in light of the evidence that you see. So hence the classical view has been superseded by the Bayesian and frequentist views. There's another issue with the principle of indifference when it is applied to the classical view, which is exposed by Bertrand's paradox, named after French mathematician Joseph Bertrand. Here's a version of Bertrand's paradox which I've taken from von Frossen's book Laws and Symmetry, though I've modified it a bit to hopefully be easier to understand. So imagine you have a factory that produces cubes with a side length between 0 and 1 foot. And we can ask, when we know this knowledge about the factory, what the average side length of the cubes are. Well, by the principle of indifference, we assume a uniform distribution over the side lengths from 0 to 1. After all, we don't want to consider some sides more important than others. And when we ask this question, what the average side length is, we get the expected value of 1/2. This makes sense, everything's good. But let's ask the same question a different way. What if rather than saying the factory is producing cubes with a side length between 0 and 1, we say it produces cubes with a face area between 0 and 1? And notice how this is the same factory, right? If the side ranges from 0 to 1, then the face area will range from 0 squared to 1 squared, which is still 0 to 1. But if we assume a uniform distribution over face areas, then the average face area is 1/2, and thus the average side length is the square root of 1/2, or 1 over the square root of 2. Well, that's not good. We got something different by basically asking the same question, just worded a little bit differently. And we can do this again, right? Rather than thinking of the factory as producing cubes with a face area between 0 and 1, let's say this factory produces cubes with a volume from 0 to 1. Note again that this is the same way of saying the factory produces cubes with a side length between 0 and 1, because 0 cubed is 0 and 1 cubed is 1. But now when we ask what the average side length is, well, the average volume of the cube is 1/2, and we take the cube root to get the average side length, and we get 1 over the cube root of 2. And hopefully you see what the issue is, right? By re-asking the same question 3 different ways, the principle of indifference has actually given us 3 different answers. And this means we can get tricked by a Dutch book argument if we follow the classical view of probability. Now, E.T. Jaynes has a reply to this in terms of maximum entropy, but this is beyond the scope of this video. Really, the point is that the classical interpretation alone appears to provide inconsistent answers due to this assumption of uniformity. Now, let's talk about another view of probability called the propensity view. As we discussed, one of the issues with the frequentist view of probability is it requires a lot of outcomes. You can't flip a coin once and then decide that the probability of heads is 0.5. You have to do it a bunch of times. The propensity theory tries to remedy this by saying probability is a sort of physical dispensation of things to eventually produce stable long-term frequencies. American philosopher C.S. Peirce famously described this view in his book The Doctrine of Chances, where he asked what is meant by saying the probability of rolling a number divisible by 3 on a fair die is 1/3. He says, quote, "This statement means that the die has a certain would-be, and to say that the die has a would-be is to say that it has a property quite analogous to any habit that a man might have." In other words, the propensity theory turns probability into a metaphysical hypothesis about why certain states of affairs produce different outcomes in the short term and then sort of stabilize over time or over repeated trials. Now, this concept of propensity is highly disputed and to many completely implausible to say the least. What exactly is meant by propensity? Does this theory really help us interpret probability, or does it just push the problem back to a new word or concept called propensity? With that said, I think many who hold to the propensity view are often pragmatists. Propensity refers to whatever plays the role of physical probability in science. And in this way, right, propensity is just a theory that says probability is whatever probability does. Regardless, the challenge for the propensity theory is demonstrating what this concept actually adds to this discussion. As Elliot Sober once remarked, saying things that behave probabilistically have a propensity to behave this way is like saying food nourishes people because it has a nutritive virtue. This idea of substantial forms was criticized in the past for giving a circular account of what's actually going on, and similarly, many critics of the propensity theory say the same, that propensity gives an empty account of probability. The fact that there is no widespread agreement on how to interpret probability means perhaps you should be careful when you hear people say probably or probably not. My guess is that this usually implies a sort of Bayesian subjectivist view, though people may be a bit resistant to admitting their use of the term as subjective and often rhetorical than strictly logical. Of course, saying probability is subjective doesn't make it irrational per se. In fact, as we've seen, adopting a Bayesian view of probability is pretty much the only way to avoid getting duped, at least when betting in these kinds of scenarios. Regardless of which view you choose, I think it's important to realize others may not interpret your probability statements the same way you intend, and may not even have a clear view of probability to begin with. Now, the view of probability that I take sees probability as an extension of logic. In classical Western logic, propositions are either true or false. Probability allows us to quantify our degree of belief or confidence in propositions where we lack actual knowledge, right? In this case, probability is an epistemic concept that reflects our knowledge of a given current state of affairs. And it turns out many others see this way too, including, of course, Bayes himself and more modern thinkers like E.T. Jaynes. This makes me a Bayesian, and I see probability statements as subjective accounts which can be rational depending on how they're updated. I should also mention that in my field, which is electrical engineering, many of us are Bayesians because Bayesian probability is closely linked to information theory, a field that quantifies surprise and uncertainty, again, primarily epistemic concepts. The field of information theory was designed to quantify recovering and communicating explicit messages in the presence of noise, where for whatever reason, a receiver lacks exact knowledge of what is sent. Now, there's a nice little paper on this link I'll provide in the references, but the key figure here is Claude Shannon, whose master's thesis was applying De Morgan's laws of thought to circuit analysis. So perhaps it's unsurprising if Shannon's perspective on probability is similar to De Morgan's Bayesianism. Anyway, thanks for watching, and I will see you in the next video.